Hey everyone, Cameron here. Today we'll begin configuring OSPF process 10 on all routers, setting router IDs, advertising directly connected networks, and making LAN interfaces passive. This prevents unnecessary OSPF hellos on user-facing interfaces. So let's get into it. All right, so here we have an OSPF setup, as you can see. We have three OSPF routers in one area, and then we have a connection going out to the internet here, and then of course a LAN network connected to each OSPF router. Pretty standard OSPF setup here. So let's get into it. All right. So just quickly, the objective: configure OSPF so each of the hosts on different networks can ping each other as well as the web server. IP information. Here's the IP information of each individual branch. We'll go over that as it becomes relevant. Tasks: configure OSPF to advertise directly connected networks on all routers. Include passive interfaces on each router. Configure a static default route on router 2. Advertise the default route on R2 using OSPF. Verify R1 and R3 have OSPF routes, including a default route. Verify hosts can ping each other. Verify hosts can browse to the web server. Step 1, configure single area OSPF on routers 1, 2, and 3. All right, so let's do this. So here's the basic algorithm for configuring any OSPF. So process ID told us to use 10, so router OSPF 10, that's your process ID. Router ID, this one's going to be 1.1.1.1. And then we can do the networks. We'll do the networks, which are, let's see here. We're going to want 19. Oh, actually, let's do this. There we go. There. 10.0. So let's do the LAN network real quick. We can drag this back over for a second. Oh, that's actually better for our purposes right now. So network 10.0.10.000.255. Yep, it's a /24 here, and we can even do this to make things a little bit easier. And area 0. Always end your networks with the area you're in. Another thing you can do show IP route. And this, and you'll see here, basically anywhere where it says C, see we just did that one, those will be your routes, because like on the CCNA exam or in real life, you might not have a diagram to look at. You might not have a diagram to look at. It might not be as easy as putting the window to one side like this and then saying, oh, okay, 10.0, 10.0, etc. It's going to look, you're going to open up a PuTTY, it's going to look like this. And then you might have your diagram in another window or whatever. You're going to get a series of instructions. You're just going to have to go. So anyway, that just makes it a little easier. You can kind of see it there in your routing table. So now let's hurry up and finish this because I just yapped for a while on 2. So now we're going to 192.168.2.000.3 to /30. That's why we're doing that. Area 0. Network 192.168. Oh, 2.0. I made a mistake there. 2.0.0. Sometimes you fat finger things. Sometimes you do it often, if you're like me. Anyway, 192.168.2.8 is the next one. 0.0.0.3 area 0. Okay, so now we have all of our networks. Let's do passive interface. And here's our passive interface right there. So interface G00. Try that. That's cool. Okay, that worked. And obviously, well, if you want to see your interfaces, that's a lot, but I mean that's one way to do it. If you don't have the diagram, the brief there, it's G00 because you want to prevent the hellos from going this way, and this network is 10.0, 10.0. So you'll know G00, 10.0, 10.0. Anyway, that's another way to do it if you can't see. So anyway, now router 1 advertises its LAN on both serial links. The LAN interface is passive, and we're good to go. So let's hurry up and do router. Oops. That's a no-no. We do not want to do that. What? Okay, there. Everything should be good. Okay. Now let's hurry up and do router 2. Oh, my goodness, I am all thumbs today. Okay, let's hurry up and do router 2. Same deal. What's this? What do you want here? make it a little easier for you to see. Okay, so now let's do router OSPF 10, route ID 2.2.2.2. Now we're gonna go network 172.16.20.0 and 0 and yeah 0.0.0.245 area 0. Now we're going to network 192.168.2.0000.3 area 0. And guys, remember, these are networks, not IP addresses, so they end in 0. Okay. So network addresses, 46%. Okay. So now let's go network 192.168.2.4.0.0.0.3 area 0. Now let's go network network 209.165.200.224.0.0.0.3 area 0. There. Okay. So now let's go do our passive interfaces. Now remember, so brief. Now let's remember we're going to have two passive interfaces here. So interface G00, passive interface G00, passive go with passive int, I guess, if it's willing to accept that G01, G001. That was a fat finger on my part. It really should just be G01. Anyway, hopefully that. Anyway, hopefully that didn't mess anything up. We'll just go with that, just to be sure. Okay, anyway, so router 2 now has two LAN-facing interfaces. Both must be passive. We also advertise the ISP-facing /30 network, which, by the way, was the 209. That's why I did that. So we have it in the instructions here. We have it in the diagram here, and I didn't really do the show IP route, but it's in the table here. But anyway, so that's going out here to the internet, basically. So that's something to keep in mind. Okay. Now, same deal here. Let's start from scratch. Router OSPF 10, router ID 3.3.3.3. Now we're going to go, let's do the passive interface right away. Actually, got it here. We'll just go with, anyway, G00. Just get it out of the way. Now we'll go network 192.168.100.0.0.0.255 area 0. Now we'll go network 192.168.2.4.0.0.0.3 area 0. Network 192.168.2.4.0.0.0.3 area 0. That should have taken. Now we'll go 192.168.2.8.0.0.0.3 area 0. Oh, network 192.168.2.8.0.0.0.3 area 0. And that should be good. Now we've got router 3 should be now advertised on its LAN on both serial links. The LAN link is passive. So we're 0000 there. That's in a full state, a loading state, change from loading to full. Excuse me. That's what we want for OSPF. That's good. That's the syslogging message that we want. So now let's configure a static default route on router 2 so we can get out to the internet. So we want to tell this to shove all unknown traffic out this interface here, so it goes straight to the internet. So okay, so let's go IP route 0.0.0.0. Obviously, that's a default route, default subnet maps. Now we're going to use the IP address of this, the 209 address that they made the internet. Oh, excuse me, 225, the network. And now that does not need a mask. What went wrong here? Okay, we want, I must have fat fingered something. 1, 2, 3, 4. Oh, That's my problem. Way too many zeros. Well, one too many zeros, but okay. IP route 0.0.0.0.0.0.0.0.0 1234 1234 209.165.200.225. That should accept, and it does. Okay, good. So again, this creates a default route that router 2 will later inject into OSPF. Now let's advertise the default route into OSPF. So let's go back. Remember process ID. Now let's do a default information originate. It's going to need this command to inject the static default route into OSPF as an external type 2 route. Basically, it needs this command to use the default route. That's kind of the way to think about it. So now let's verify our OSPF routes. You'll see this is now at 100. But let's verify. So we need to verify specifically that router 1 and router 2 have learned all remote networks, including the default route. So let's go to router 1. Let's go with, exit out of that. We'll go do show IP route. Okay, so we want to look for 172.16.20.0/24. So that network is in there. Oh, there we go. That's what we want to see. And we have the AD for OSPF. So, and OSPF, now we want 192.168.100 0/24. And we do. That's working. Now, we also want the default route. Oh, there we go. See, and we want it. See, then we want that little star there. See, as you can see here, that little star indicates a default route. But anyway, and then E1, OSPF external type 1, or excuse me, 2 in this case. So anyway, and then the OSPF AD and a static, and 1 means static. So anyway, via 192.168.22, that's exactly what we want to see. Via serial 000, which is exactly what we want. So you can see it there. So that's exactly what we want. And router 3, we're going to check basically the same thing. So do show IP route. Let's pull this up. Okay, so might as well just start from the bottom. It's there. We see it. Same deal. The static route, the default route, OSPF 110 static 1 via 192.168.2.5. It's serial 001. That's exactly what we want to see. This right here, like we talked about, the O asterisk E2, confirms the route was injected into OSPF as an external default route. That's exactly what we want to see. And then same deal here. We have this network, which is exactly what we want. 172.16 blah 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 192.168.25. That's exactly what we want here. The via to basically means like this is a static route. Basically, it's where are we going and how are we getting there, using this route to get there. Anyway, and 10.0 10.0. So we have that's working. 172, and so we're good there. So now everything looks good there. So now let's verify connectivity and web access. So let's go to PCA with host 1. Let's go to host 1 anyway. If I could get around these stupid windows, that'd be great. There we go. Sheesh. Okay. Now let's go ping 172.16.20.20. Let's cheat a little bit. No, we don't. Speed this up a little. And it worked. Okay, great. Now let's ping 192.168.100.30. Again, let's cheat a little bit. That does not want to stay open. That top button's supposed to keep it open, whatever. Again, it worked, which is great. Okay, now let's ping Google 8.8.8.8. Okay, that's timing out. Okay, Google did not work, so that's okay. Let's ping www.test.com. Maybe the web server isn't set up correctly or set up, but anyway, that's okay. Well, anyway, the web server might not be set up, but they're from out of curiosity. I want to make sure it's dying from the router too. Yeah, okay, that's fine. Okay, well, let's ping our hosts. 172 at 16.20.20. That's working. 192 to 168.100.30. Good, good, good. Now 8.8.8.8. Probably. Okay, so that's not same deal. That's not working. Okay, well, let's just try this. But we are able to ping the hosts. We're getting the OSPF syslog message that we want. So that's good. So that's working also. Yep, that's working. So all hosts can ping each other. Only thing is the web server isn't quite working. So let me just so the default route might be broken. Maybe, geez, these little labels are not making my life easy. Okay, so let's check. Okay, we have. So the fact that I can't get out to the web server ping Google, that suggests to me there's something wrong with the default route and default information originate command, because that's what's getting us out to Google, as opposed to anyway. But we have S asterisks plus our default route, static route 1 via 209.165.200.225. So okay, that looks good. Now let me check. Run pipe section OSPF. Okay. That's in there. That pretty much isolates it to the between the router 2 and the ISP web server, or the web server's default gateway. So let's do another show IP route. Interestingly, packet tracer is showing me that I'm at 100% completion. So that's interesting to me. I want to see O asterisk E2 40/0/110/1 via 192.168.22. And I do. You should see the same thing on router 3. You should. So 40/0/110 via 192.168.25. Yep. And 0 asterisk E2. Yep, that's working. Okay. Now let's go back and look at this. It's between the router and the web server, or the problem is the web server itself. So let's even try. Okay, actually, let me try something new. Do ping 209.165.200.225. Okay, so that's interesting. That works. And do ping 8.8.8.8 again. Double check that. Okay, so that's not working, but we can ping. We can't ping this. Okay, so that's good to know. The interface towards router 2 is up and answering. Router 2 has a working default route to 209.165.200.225. At this point, if the ping to Google fails, it's definitely the web slash DNS server isn't replying to ICMP. Come on. Oh. Well, there's our problem. Those aren't connected. Oh. Quite simply, looks like layer 1 might resolve our problem. See, all right, so we can ping And it's working. So it's from host 2. We're able to ping Google from host 2, which is great. Let's see if we can ping test.com. And it's working. Yes. Easy. Boom. Done. Okay. Now, that completes the OSPF default route lab. We configured OSPF on all routers, added passive interfaces, injected a default route from router 2, and verified full connectivity across the network. Now, again, the solution here was simply that the web server was not connected to the router or the switch there. So simple layer 1 resolution, and that restored access. So now we can ping across the entire network to Google. So it was really that easy. Sometimes it's that simple. And thanks for watching. If you want me to build a thumbnail, YouTube description, or another lab script, just let me know. Or if you want me to cover another topic, let me know. Maybe we can make that happen. Otherwise, thanks for watching, guys, and come level up with me in the next video.